Alright guys, this is going to be test 3 of this experiment, and so like I said, we got the paper gasket in here because that was leaking, because that multi-layer steel gasket right here, this is a factory one, and it just would not seal. It was cheap, it's not a Honda brand, so that's probably what's going on there. And so I know this throttle body does leak right here from the throttle arm. I have a backup plan if we can't get this thing to pop because of that. Is I have a old plenum over here. This is an old test plenum. This one held 38 psi before it leaked. This is a much older design, but on this one I have this plate I printed right here that takes the place of the throttle body. So if we can't get it to build up enough pressure because of that leak in the throttle body, we'll just switch to that and try again. Got it all RTV'd again, everything. You want to try to blow this up?
I'm ready.
Alright, so I'm going to start data logging on this. Alright, she is data logging.
Push your pedal, check to see if it's moving on here.
Yeah, she got it. She got data.
Alright, I'm going to put a little in.
Alright, put a little in. The engine load right here, that's how much pressure is in there.
Ready?
Yep. It's doing. Dump it. At 10 psi, where's it leaking? Alright, go ahead.
Oh, I hear it right here on this.
Same spot over here on this side.
I think I feel a little bit on the same spot on this side. A little.
Yeah. 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 Why isn't that plate sealing? Yeah. Throttle body gasket's leaking too. But it's not leaking from the plate, it's leaking from the gasket. What the heck? Never had this many problems before. Alright, so as you saw, bad news. It is still leaking. It's not leaking from any seam on the actual manifold itself. It is leaking between the aluminum plate here and the lower runners. That gasket's not sealing either. I'm wondering if this plate has a slight curve to it. Same, and now the manifold, or now the throttle body is leaking right here. Not on the seam between the manifold and the plate, but between the plate and the throttle body is leaking. So I'm thinking these might have a slight curve to them. I know a guy who can deck these down flat. We just gotta take it all apart, take it over there, and see if he can deck those down. He wants me to 3D print stuff for him, so we can probably just trade favors and get that done. But everything else is solid. None of the seams on the actual manifold are leaking. The throttle body gasket I made isn't leaking. It's not leaking on the RTV, and it's not leaking on this seam right here. So the manifold is holding up. It's just the gaskets on the ends of the manifold are leaking. So,
and another thing we didn't bring up in an earlier video that we thought of was just like the volumetric of air. When we dump the tank that we have, which is 15 gallon or 20, 10 gallon.
10 gallon.
When we dump it into here, this is probably like three gallons, probably 3 gallons in.
2 or 3, yeah.
Oh, with the runners, it's probably 3 to 4, yeah.
Yeah. So
so you gotta remember, we're not going to see 100 psi hit this thing. We'll probably it should be probably around 30s, 40s. Yeah. Once the air pressure comes down, but it survived that. It did it.
Yeah, she hit about 15 pounds on that last one. I'll have to look at the data logs. But she hit about 15, and then went down to 10 once she started leaking. But
let's check the data logs and let's check those.
But yeah, but that's about all we can do until we gotta get this all apart, get it over our friend Josh's house, and he can deck those down. He's got a big old giant sandpaper plane piece. I don't know even what you call it.
So he has a giant sanding, or I guess you'd call it a decking stone. It's probably 24 by 18. It's probably 5 inches thick. And they use lasers to make that thing flat.
It turned off.
Okay. And so when you put sandpaper on it and you run your heads or your whatever you want to run across it, you can see where it wears on the metal.
Yeah. And we'll cover the plate with Sharpie pen before we do that, just so we can see if there's any high spots or anything.
Yep.
But yeah, we can't really do anything else, so we're back on pause. Yep. Research and development. Gotta love it. Yeah, but like I said, all we can do is make these flat. That's the only thing I can think of why it would be leaking. Because nothing on the actual manifold is leaking. It's the gaskets on the ends that are leaking. So, but I think that's just going to have to do it for that.
Yep, and I'll keep on trying.
Yeah.
Alright everybody, it's Mike on the camera today. Chris is at work, so while he was at work, we put this all back together so we could do another test. The key difference is we got you probably can't see it, but there is a purple TPU gasket there. We have a nylon barometric gasket down there on the runners. And then the top is just the standard bolts and RTV or black silicone. So we're gonna let this dry up. We got this all done. So we're gonna let that dry overnight and test it and blow it up tomorrow.
Alright, so I made a few changes. I remembered I had this big old P2R gasket right here. It's about like, I don't know, like 3/16 of an inch thick. It's pretty thick right there, so hopefully that'll keep that from sealing, or hopefully that'll keep that from leaking. Stay nice and sealed. And I also 3D printed a gasket for right here. This is at a TPU. It's like a rubbery material. That's what I did the map sensor gasket out of and the air intake temperature sensor gasket out of. And they seem to be holding pretty good, so I went ahead and did it for that one. So manifold itself has not leaked yet. It's just been the flanges on the ends where the other stuff bolts to. So just got to get those gaskets good. We got the air compressor all aired up, computer's hooked up and running. So
slide this over the window.
Yep. Just in case something explodes, because we don't know how much pressure this is going to hold. I would like for it to break. So, alright. So we got data log going on here. I'm about to start it. Start logging. Computer is data logging.
I'm gonna start it opening there.
Yep.
I'm gonna give it a little burp again.
Yep, just get a little bit. Well, that moved.
That sounded really good out there.
Throttle body's still leaking, but
like throttle body.
Yep.
A little more again.
Yep. It's moving, yeah, a little bit. All right, dump it.
All of it. That's it. That's everything.
Where's it leaking? Well, it's even worse over here.
Oh no!
I can't get the spray on it.
Give me that. You want to see some of that? Yeah, it's all over the place. Same thing. Yeah.
Oh wait, is it coming from the? It's coming from where the plastic meets the metal.
I think it's.
Yeah, it's cool. See it?
That one's coming from the rubber right here. That top one's coming from the rubber, though.
Ooh. Check the throttle body.
Yeah, see, it's only on that side. See that bubble?
Yeah, it's up top.
Shit.
So the manifold is actually leaking for once.
Okay. Little rubber on that side. Okay.
How's this?
It's more in it.
No, it's still leaking. Okay.
Everything leaks.
That's even worse. Damn it.
Everything's worse.
Alright guys, doing one more test. After careful examination, the plate that I was using on the bottom of the manifold that's attached to it, the flange, was actually bowed slightly. Put a straight edge up to it and you can clearly see a gap. So I took it and sanded it down on the floor right there, so hopefully that's nice and flat enough.
It was on sandpaper.
Yeah. Sanded down on the floor on sheets of sandpaper and hopefully got it nice and flat. And we're going to try this one more time, get it all RTV back together again. Also, we got rid of the throttle body. I put this test plate on here. It's what I was testing the last version of the manifold with. And instead of RTVing on, we got a TPU gasket here that I 3D printed. So, because that manifold, or that throttle body was just leaking really bad out the throttle arm. So we're going to try it again. We got the air compressor all aired up.
We're gonna flatten or mill the face of that throttle body too.
Yeah, yeah.
And you're gonna get a newer, better, upgraded one too.
Yeah, we're gonna, instead of getting these plates laser cut, the heat from the laser is actually warping the aluminum plate a bit. That's what's causing that bowing. So I'm probably just gonna have to pay the money and get it CNC cut. So that way we can get the faces nice and flat. So
Alright, data log on.
yeah, I'm gonna start data logging right now.
Alright, let me get the charger on.
Computer is data logging. We got our gauges here.
Alright.
And go give her a little bit.
I'm gonna give her a bump.
Oh, she's leaking somewhere already. Okay, here's a little bit. Yeah, she's still leaking from there. Not nearly as bad.
I think we're solid here. Don't squirt it. Yeah.
Solid on that side. Just still leaking a little bit on this side. Not a whole lot. Check the throttle body flange.
From this angle when you get done with that. That looks like it's coming straight out of the material.
Yeah, that's gonna go on plastic. This one's not quite epoxy enough.
Yeah.
Yeah. Alright, give her full blast.
Alright.
See how much she holds.
Ready?
Yep.
You ready?
It's only at 10 pounds. No, there's valve. So it's leaking really, man. It's getting worse out of that test plate. Oh man, I'm gonna have to RTV all this together to get a good test.
Well, if we got our RTV together, we got our RTV together.
Yeah.
Back home.
Alright, we're gonna try that test again. So because that throttle body plate was not that tight, I hit it with a little mini impact, but it didn't actually get that tight. So, all right. Start a new data log. I already deleted that last one. It's not very valid. Alright, it's logging.
Don't delete that log, but.
I did.
Alright, well, you ready?
Yep.
I'm gonna hear a song.
Blast it. This is bad. Alright, so as you saw, she's leaking again. It wasn't the gasket this time, thankfully, but it was where the aluminum plate was actually bonding to the carbon fiber. So, and the epoxy we used was a little too stiff, so it actually ended up cracking, and that's what caused the leak. So I know this is going to be a permanent solution. I just took some RTV, basically sealed it around the edge, and I did that with a vacuum pump hooked up to the manifold, so hopefully it'll suck that RTV in a little bit. And because I just want to get a strength test on this, I am looking into some new methods for attaching the aluminum plate to the carbon fiber. So I got the gauges all hooked up here, and I'm gonna film that while I go out in there and turn on the compressor, and we're gonna see what she does. So, no longer leaking from the seam on the edge. Now she's just leaking from this, which is the problem I had before with this test setup. But she held a lot of pressure last time. That was only a few pounds this time. So I'm gonna let it compressor air up as much as it can, and then we're gonna see. We can just blast a whole bunch of pressure out of this and see how much pressure we can get under it. Ooh, the cluster capped right off. That's a good sign. Alright, so the reason this popped off was this clamp actually broke. So I went ahead and sourced another one. Got it on there. I don't know if it's the threads in the nut or this shaft that actually stripped out. But I'm going to try that again. I got the compressor all aired up. And let's see what happens. Alright, so that test actually held on this gauge by 25 psi, but this one is off by about 3 psi. On this gauge, it was a little over 20, so we're going to call that 22. That's just the most pressure we can get in there with the compressor because the leak right here, this plate is flexing out a little bit. So now the next step is take this back apart, put it on the car, because that won't flex or leak. It seals it pretty good on there. And we're going to see how much pressure we can actually put it under. The goal is not to actually make this thing seal, not per se. Sealing would be nice, but we're just trying to see how much pressure we can actually put this under without it breaking. So, but I'm going to go ahead and take this back apart, take that plate off, and we'll see how much pressure we can do. Alright, so I got it all RTV'd together. We're going to give it another go. And I got the gauge on it, and let's get this camera going. Camera's recording for data. So we don't have the ECU in the car anymore, so we can't data log this because of reasons I'll tell you about later. Hit it. Yeah, it's leaking around the plate. It held before when I was testing it with the other thing, but now it's leaking, so get rid of one leak, find another. Alright, so I got to take that plate off, and we're just gonna have to do a different manifold because that one's epoxied on. So alright everybody, so the last time we filmed, we managed to get this thing up to like 25, 27 psi. Then it started leaking at the seam between the aluminum plate and the carbon fiber. What happened was the epoxy we were using is really strong, but it's really brittle and it cracked. So, and at 27 psi, there's actually 1,400 pounds of force trying to rip this manifold off the aluminum plate. And with 10 screws, that's 140 pounds of weight on each screw. So what we have done is I got a new plate made here, and this has 22 screw holes in it, and I printed a new manifold lower half, and it also has the matching 22 holes. Got these all countersunk and everything, and instead of using epoxy, what we're going to do is I got some windshield adhesive. That'd be a lot stronger and hopefully have just a little bit of flex and give to it so it's not so brittle. So I'm going to try and find the caulking gun, and
It should be over there somewhere.
oh, I see it right there actually. It's right there.
I see it. It's
I
red.
see it. And we're going to get the caulking gun. We're going to put some nice bead around every single one of these holes. And then screw this on. And then I got to clean up the bolt holes. Make sure there's no excess that gets going down in there so the bolt can go all the way down to the aluminum plate. guys, so got it all together, got it on. Said quite a few differences on this one. This one has 22 screws holding the plate to the bottom of the manifold, and the plate on the throttle body has 14 screws instead of 8. So it should be a lot stronger now. Don't really have multiple cameras, so I just got to pretty much stand here and film this as it rises in pressure. Don't worry, got my safety glasses on. Yeah. So just in case it does blow up in my face, you know, we'll see. And we do not want to pressurize this to max. We're just going to take this up to 30 psi and call the test there, because this manifold is actually going off to somebody first thing tomorrow morning. So, you know, actually, no, first thing tomorrow after I get off work. So can't break it. So hopefully not. So, all right, got the air compressor all filled up, and go ahead and start filling her up. So I'm about to open the valve and see what we can. Oh, turn off the compressor.
I did.
Okay. All right, that was 15.
About 75%. All of it.
All right, stop. Right now, somewhere else. I think it's on a hose.
Feel a little bit. I feel nothing down the side over here
No.
by the injectors.
Slight over here. I feel like the gasket is leaking. That's fine. Yeah, gasket is leaking slightly.
Yeah, that's something over here.
Probably on the gasket as well, because I reuse this gasket.
Yeah. No, not there.
Alright, well, that's good. Alright, so we're going to try this one more time, see how much pressure we can get in here. It is leaking a little bit from this 3D printed gasket that I did, because we're reusing it. It didn't leak last time, but we're reusing it, so it's probably smashed a bit. But we got the throttle blade all wedged open, get some more airflow into there, hopefully slow down this leak that's on the throttle body. And we got the air compressor all filled up. I'm going to hit it again. Just open it all the way. Yeah, all the way 25. I think it's leaking from this, from over here. Sounds like it's leaking on the fuel pressure regulator. Whenever you're really hitting it, so I hear it leaking over here. It's holding. All right, cool, success.
Oh yeah. Finally.
Yeah, finally, gonna kill it. All right, I'll call that a success. She went all the way to 25 psi and then some. She went a little bit past it. And I don't think he's going to be running much more than that, because that's a lot of power on a J-series with this manifold. He'll definitely be going fast on that. So about a month later, we can finally end this video right here. So we've been doing these pressure tests for a while now. You know, making different versions and different seals, all kinds of stuff.
Oh yeah, and we use different sealant.
Yep. Right now, it's this is still RTV between these two layers. But as I told you guys earlier, on between the aluminum plate and the intake, between the aluminum plate and the carbon fiber, that is actually windshield adhesive. So a lot stronger, a little bit flexible, not as brittle as the epoxy we were using. And a few other changes, but score.
And if you have a question as to why we don't use that window sealant on the top half, we need to get the top half back off.
Yeah, the RTV is hard enough to get off, you know. So, like I said, gonna go ahead and end that video right there. Thanks you guys for watching, because it's been a rough ride these last few weeks. So, say goodbye, Mike.
Hell yeah, goodbye. Titties and beer.
Yeah. Yeah.